And welcome everybody to the Daily Space Weather. We've got a filament fest continuing, a little uptick in the X-ray flux, a high likelihood of large solar flares, and lots more to bring you today. From the Smash News Network, least busted name in news. This is a 24-hour video from SDO. Most active sunspot is the one right in the Earth-facing zone, right there in the center of solar disk. Let's zoom in and add 193 angstroms for some additional contrast to all of those plasma filaments. We named two of these filaments, this one right here and this one right here. Join us over on Twitter if you want to name solar filaments after living people. Just follow the hashtag #NameThatFilament. Anyway, we've got a crown prominence once again up here at the North Polar region, and you might see a whole lot of snaky rope-like features all over the Earth-facing portion of the solar disk. Those are indeed plasma filaments. Those features are known to turn into coronal mass ejections. Sometimes they collapse, sometimes they reposition themselves, and sometimes they're headed right toward your doorstep. And indeed, right now there is one headed this way. We call it the Selena Gomez filament, as suggested by one of our viewers, again over on Twitter at SmashOmash. So the most active sunspot region has been the one just north of our Earth scale there. There is still a very high likelihood of large solar flares up in the northwestern limb as well. That will continue for another day or two, as sunspots are able to produce large flares even when they are out of sight. Next, the South Polar region here, and check out that huge prominence over there to the west of the Earth scale. That's the Eugene Bagashaw filament. Having now started to hang off the edge of the solar disk from Earth's perspective, it is now a prominence. Anyway, let's take a brief look at sunspots here. And before we do that, thanks to our new subscribers. Congratulations on realizing the channel exists. We're frankly surprised that you have. And if you want to share our videos with people with shorter attention spans, check out our shorts. So putting up highlights on the daily, doing incredibly accurate forecasts for when hurricanes are going to break down, when solar flares are likely, coronal mass ejection impacts, and even the occasional cosmology segment. So once again, thanks to our new subscribers. If you're new to the channel, press that subscribe button and do yourself a favor. Get the world's most comprehensive daily space weather and most detailed imagery of the sun you'll find in the known universe. And if you're not new to the channel, press like regardless. And don't forget to visit our links. We created a massive web ring starting back in February of 2019. SmashOmash.com is what we're talking about. And, yeah, check it out. It's the official homepage of the Smash News Network, least busted name in news. The controversial facts that we cover daily are indeed the world's most comprehensive daily space weather content. Thanks to the Smash Team, as these videos are brought to you in part by Gold and Silver Smash Team members. If you didn't see yesterday's videos, you might have missed this. How you like that for an incredible conflagration? The Daily Space Weather Show. Anyway, here's yesterday plus today in the SDO intensity gram, and things have been rather stable here. So we've got some sunspots that are looking like they're breaking down here in the southern hemisphere. The action is in the north, so there is a high likelihood of large solar flares up here at the northwest. Also, this sunspot is capable of producing large flares, and this one here has been the main producer of the M-class flaring events we've seen in the past 24 hours. We'll also show colorized magnetogram. Again, that is yesterday plus today. That is September 14th and September 15th to date. There are some new active regions rising in the east, which we'll go over here in a moment. First, we've got some new volcanoes on the list. Mutnovsky, another Kamchatkan volcano there, producing an unknown size volcanic ash plume. So yeah, never heard of it. It's new to the list. Another Kamchatkan volcano there on the Kamchatka Peninsula. Kluchevskoye also erupting now, back on the list, as it effuses and explodes. No indication on the ash plume size there from Kluchevskoye either. Subanose Jima, producing an 8,000-foot plume of volcanic ash. Mount Mayan, unknown volcanic ash plume there over Philippines. Semeru exploding, flight level 140 over East Java, Indonesia. It's a 14,000-foot ash plume. Shishaldin. What's up with Shishaldin? Following increased tremor, the seismic unrest has reduced. So, not sure, as visibility was low at Shishaldin. It could be erupting. If so, it's low-level ash emissions. Popocatépetl exploding, flight level 220 over central Mexico. It's a 22,000-foot ash plume. No emissions from Sangay. However, Sabancaya in Peru producing a 23,000-foot volcanic ash plume and a 21,000-foot ash plume from Ubinas, as it also explodes. It's a flight level 210. Please do not pole vault the caldera. Seismic activity there over the past 90 days. And let's see what's been going on over the past 24 hours. We'll call out quakes of a 5 or greater magnitude. Starting out the list is a 5.2 at Colombia at 14:25 Universal Time yesterday, near the surface there. Then Papua New Guinea at 1958 Universal Time. That 5.6 magnitude at Papua New Guinea was at 62.2 kilometers estimated depth. Next, in a very desolate portion of the planet, a 5.6 struck at 22:51 there in the southeastern Pacific. Not a lot of people likely there to have felt that one. Papua New Guinea had another 5.0 there at 23:15 Universal Time. South Sandwich Islands had a 5.1. And then like 3 hours later had another 5.1. So on both sides there of that plate boundary between the South Atlantic and the Antarctican plate. So those are the earthquakes that have been shaken over the past 24. And let's take a look at the sun here in the house favorite wavelength. And it looks like we may have some new active regions rising here in the east. So you can see one up there and one down here south of the equator. No new sunspots so far. Here's a little closer view of that. Another 24-hour video from Solar Dynamics Observatory. Next, the 10.7 centimeter radial flux is now at 143 solar flux units, I think. 143, is it? I think it's 143. 145. So there is the 1 year graph of the radial flux depicted by the black line. The red line is the sunspot number. Those are the two most important features as far as solar activity goes. They are directly proportional. In other words, when you see a high sunspot number, you see a high radial flux, and vice versa. That's from solon.info. And we're still like a year out from solar maximum at least. And check it out, expecting geomagnetic storm conditions early in the day on the 17th. So on Sunday, you may see some aurora if you get up before dawn. It should be a good time to view aurora, as the moon will be very small in the sky at that point in time. So, yeah, some possibility there for seeing the aurora on Sunday, September 17th. That's the Space Weather Enthusiast dashboard. That is a CME that we talked about yesterday. That's the Selena Gomez plasma filament about to strike Earth. Next, the last 4 hours of Earth's magnetic moment from space, Should be the last 4 hours if all is working correctly. And we have seen some coronal hole activity here showing up, creating a little bit of space weather at Earth. They have been mild coronal hole high-speed streams. So that's the last 4 hours of Earth's magnetic moment from space, our geospace magnetosphere movie. It depicts magnetohydrodynamic pressure. Here's magnetic flux density from the ground level. Again, it should be the last 4 hours. This will show you the most likely places to see telluric currents. The most likely places to see the aurora, pipeline, railway, and power grid induction. It's our ground magnetic perturbations map. It's shown daily on the channel. And things are pretty geomagnetically calm here on planet Earth at the moment. Mild geomagnetic storm on the way. Anyway, there's the KP index. KP1 is the current situation. Again, very geomagnetically calm at the moment. And let's take a look at the real-time solar wind here. What do we have? About 6.5 protons per cubic centimeter for the solar wind density. Solar wind velocity here, 459 kilometers per second. Those are calm conditions. GOES magnetometers, fairly smooth there. One spike showing up on the GOES 18. Making it up to around 165 nanotesla there. No major changes on the GOES magnetometers. Again, those coronal hole high-speed streams have been weak. Next, here's the heliospheric current sheet. And that North Pole current sheet is looking weak as well. So, Earth may be in an indecisive environment here as far as the polarity of the solar plasma. If you look at the last image, there is no North Pole current sheet coming, but if you go back a few frames, there it pops up. So it looks like it is largely gone. And we may indeed see some, like I said, some new sunspots there rising over the eastern limb in the coming 12 to 24 hours. So that's the polarity of the solar plasma. Like we said yesterday, it looks like that current sheet may be canceled. Earth is just in a South Pole current sheet here at the moment. So here's our line of sight field plot. That's what's going on with the B field. That's the blue portion. Polar fields in green for north and red for south. And let's go to coronal holes. We do have a few coronal holes here. They are expected to tick up in the coming 2 years. At the moment, they're not all that well defined. And let's take a look at coronal holes from SDO before we move on to sunspots. So there's the past 24 hours in SDO. We've got South Pole coronal holes. These are North Pole. That's a North Pole coronal hole system setting up there. And it is sunspot time. So here's what's going on with sunspots. We did get a new group name down here, 3431 in the southern hemisphere. It looks like it's degrading rapidly. So the action is really in the northern hemisphere. We've got multiple beta gamma delta class sunspot groups up there. And let's take a look at those. Once again from SDO. There's another 24-hour video. It shows the SDO continuum in 94 angstroms wavelength. One of the best wavelengths to view solar flare activity. And let's subtract the 94 angstroms to show sunspot evolution. So south of the Earth scale there, you should see some sunspots degrading a bit. North of the Earth scale, you'll see the most active sunspot. And up there in your upper right, at the northwestern limb, two other magnetically complex sunspot groups. The one on the lower right is also significant, although it looks like it has degraded a little bit in the past 24 also. Next thing to cover is solar energetic particles and solar flares. So there was a minor SEP just after midday yesterday. It has already subsided. It didn't likely cause any polar radio blackouts. Little spike in the proton flux there. X-ray flux did feature 2 M-class solar flares in the past 24 hours, and of course this long duration one early yesterday morning. So we have seen a little increase in the X-ray flux overall. So over the past 24 hours, the average flux is probably something like C5 because of a series of solar flares. So let's take a look at those, shall we? Just kidding, I'm not really asking. So here's 94 angstroms, a 24-hour equatorial zoom. We place the Earth scale to the south of the most active sunspot region. Here's a little closer zoom. We'll also show 131 angstroms from this same perspective. And then we'll zoom back out. So again, northern hemisphere most likely place to see large solar flares, especially in the northwest. Those are the facts. And let's take a step back. Those are facts. Let's take a step back and see what's going on overhead. So this is what's happening over Lehigh Valley, Pennsylvania. If you are up before dawn and you have a clear sky and a low horizon and low light pollution, you might be able to see Mercury there. Jupiter up high on the ecliptic. Also Venus rising ahead of the sun, the third brightest object in the sky. If you want to make your own, check out skyandtelescope.org. I like it. I find it to be very convenient. Next, the solar system forecast. So that's where things are now. And happy new moon. My favorite phase. It lends to people sleeping well at night, not cannibalizing each other's and turning into werewolves. Shout out to all my reverse werewolves who sleep restfully and become productive members of society the next day. Did you know that humans are diurnal? Yeah, humans are diurnal. I know, you might think you're nocturnal, but you're probably just damaging your health by staying up all night. You should really sleep when it's dark and be awake when it's light. Anyway, here comes the 1 week forecast for the solar system. Here's where things will be on the 22nd of September. We will have a crescent waxing moon by that point. And check it out, here's the astronomy photo of the day. Now, Venus is now visible in the morning sky. It is the third brightest object, and that's what you're seeing there. There's Venus. And there's the second brightest object in the sky. That's the moon. And then, as we scroll down a little lower, you'll see a bright object in central Mexico, the volcano known as Popocatépetl. So that's the astronomy photo of the day there. Venus, the moon, and Popocatépetl. You can find it yourself if you like at apod.nasa.gov. It looks like it's taken from a plane. That's Mexico City down there in the foreground, I suspect. apod.nasa.gov. Now, brief cosmology article. We showed this a few days ago. This galaxy has perhaps a not so uncommon orbiting mass of hydrogen gas. So that's actually radio frequency there. That pinkish gas there, that is hydrogen gas, neutral hydrogen gas, orbiting that galaxy perpendicularly. So it might seem like a very odd thing, but it's looking like it's more common, actually. whether it's caused by emissions from the galaxy or interactions with the galaxy and the external environment. So perhaps it's interacting with another galaxy and siphoning gas off, or is it emitting gas? We're not really sure yet, but there are some studies being done there about that. So polar ring galaxies perhaps not so rare after all. That article you can find on scitechdaily.com. Perpendicular orbiting rings of hydrogen gas. So hydrogen gas is the most common element in space by far. And not only the solar wind, but cosmic rays are generally composed of almost entirely hydrogen. Something like 90% hydrogen gas. And that ring galaxy is known as NGC 4632 from the New General Catalog. Continuing on to coronal mass ejections. We may have one early this morning here, and it could be another earthly directed one. However, I suspect it is on the far side of the sun, moving away from Earth, not toward. So these are yesterday's coronagraphs. That's 81 frames from September 14th. Here are today's frames. Oh, okay, sweet. We've got some additional imagery here. So what do we have here? We do have a halo-like eruption there. I suspect that that is on the far side, like I said. That's 31 frames from today. Let's take a look at some more imagery here. Soho Lasco C2 and C3. So it looks like multiple events actually happening there. Let's break those down at the Integrated Space Weather Analysis Center. And we're going to pause to look at early this morning. And we got a bunch of missing data there. That is suboptimal. All right, these are actually better. Sweet. This does happen occasionally, folks. Different websites have different feeds. And let's see what we have here. So there's a CME. That one looks like it's coming out of the eastern limb primarily. First thing this morning. And then there is a second event. More out of the north. So let's see what we have here. If we have any other imagery on stereo A, that might help. What do we got? So here's this morning. We're going to bring this back. It's a very diffuse CME there around the east. Let's bring this back. So there you can see that one on the east. And then what do we have here? Second one coming out of the north there, not showing up on the imagery. There it is. You can see a little bit the beginning of it there happening just recently. So it might be too early to even see that. Let's cut to 193 angstroms. And I want to see if we have any plasma motions here on the Earth side of the solar disk. So I don't suspect that those are earthly directed coronal mass ejections. So we are still expecting one to impact. That'll be the Selena Gomez solar storm to show up early in the day on September 17th on Sunday morning. So it might be a reason to get up before dawn there. You might have a great view of various things there. Venus and Mercury and perhaps some aurora at mid-latitudes, we're hoping. Besides that, no new space weather likely on the way. And let's take a look at filaments, as those are known to turn into space weather events. So check it out. Here's the filament situation. We decided to name these filaments. This one here is the Tamitha Scove, and this one over here is the Scott McIntosh. And it looks like the Tamatha-Skov filament might be getting a little bit unstable there. So fingers crossed that that will turn into a solar storm, in which case it'll turn into the Tamatha-Skov solar storm. That would be pretty sweet. Anyway, that's the hydrogen alpha imagery from El Teide, Spain's ground-based solar observatory. We'll also show the grayscale, so it shows prominences. The Eugene Bagashov filament prominence down here. And once again, if you want to name filaments after living people, name them after your friends, name them after your foes, name them after yourself if you like. Over there on Twitter, just follow the hashtag #NameThatFilament. Thanks to our new Twitter followers. Congratulations on realizing the channel exists. Congratulations on realizing the Twitter account exists with the pathetic state of censorship. No, Twitter has not fixed free speech on the internet. Don't be delusional. Here are the past couple of hours from the GOES 16 SUVI. And indeed, we are seeing some instability with this Tamatha-Skov filament. So, is it going to produce a coronal mass ejection? Is it going to cause a solar flare as it ejects? Yeah. It's looking increasingly likely, folks, that coronal mass ejections cause solar flares, not vice versa. So, just so you're aware of that. And let's get to our bonus features segment. Starting out with satellite charging hazards. We ain't got none. It's smooth sailing. No high-energy electrons building up inside of spacecraft, and no low-energy electrons building up outside of spacecraft. GOES electron flux here, kind of low. And again, those coronal hole high-speed streams have been sort of weak. So no major effects there on the GOES electron flux. There's the one-year graph just sort of in the middle of the range, sort of a mode there. That's the one-year graph from Solon.info for the greater than 2 mega electron volt electron fluence, or electron flux. Here's NOAA's forecast, expecting an uptick in the electron flux, and I would tend to agree until Sunday when the CME impact happens. Then you can expect another cratering of the electron flux. So I think NOAA's going to be off on one of these forecasts here. The green boxes represent the forecast. The yellow diamonds represent the observation. We'll also show the F-flare of the ionosphere. We show it daily because you never know when immersion in the data is going to produce unknown effects. You know, the weird thing about science, folks, is that we all ask the same questions, and then usually we don't end up with answers to those questions. We instead, if we're doing it correctly, end up with more questions. And sometimes we end up with answers to questions not asked. So you never know what will happen when you immerse yourself in the data. You might find yourself explaining this mechanism that underlies the solar sunspot cycles. It's pretty bizarre, really. And if you want to read all about it, become a gold member at the Smash Team, smashomash.com/Smash Team. So that is the vibrational frequency of the ionosphere. It's the bridge between Earth and space in megahertz. And things are looking pretty normal here. Again, no major effects of the most recent coronal hole streams. There's anomaly in megahertz from a 30-day median. We are seeing a lot of that red subsiding there. The red depicts low-frequency anomalies, and the blue depicts high-frequency anomalies. We'll briefly show the latest image. That's when the video was produced, around 10:15 Universal Time. There's the ionogram, and there's the anomalygram. Again, things are subsiding here. The ionosphere returning back to its more normal mode. Total electron content is free electrons up to about 12,500 miles of altitude. That's where your GPS satellite's located. Here are the most likely places to see GPS errors. And things are looking pretty organized there, at least for the first half of the run. No major electrons out of place there. It's the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. Your GPS has to communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere to get your signal to your handset. And that signal can be refracted by those free electrons. That's why this is useful for everybody using GPS to navigate. We also show the total electron content anomaly over North America, and yowzers, some major high electron content anomalies there. Some wild swings there from the 10-day average. Check it out, some huge electron content anomalies of the high electron count anomaly over Mexico and Central America. That's centered right there around southern Mexico there, west of the Yucatan. That's one of the more significant anomalies that we've shown since we've been showing this data set. So again, this is literally a count of electrons, their departure from the 10-day average. Huge signal there, showing up around southern Mexico. And we'll close out the space weather section of the video with the latest intensity gram and the latest magnetogram. So again, we don't see any new sunspots over here yet. That is just a plage. We don't see any dark ombre. No major changes. Likely places to see large flares are the northwestern portion and right in the center of the solar disk. This sunspot down here is also magnetically complex. It is beta gamma class. There's the full disk rockback. Again, the central disk and the northwestern limb are where you can expect to see large solar flares in the coming 24 hours. Before we get to meteorology, please take a moment to visit our links. We've got paid affiliates/sponsors, where we offer some great shopping ideas for people just like you. The Amazon shop includes spices, coffee choices, spaceware, even some suggested reading. Don't forget camping supplies, items for your kitchen. It's amazon.com/shop/smashomash, so check that out if you haven't. We've also got the Hemp Lucid shop there. It's linked below the video, just like the Amazon shop. So if you're in the market for mushroom gummies, CBD tinctures, and the rest of the products available there from Hemp Lucid, hit up the Hemp Lucid shop. You can also find a link to that on the homepage. Thanks to all of our affiliates/sponsors for increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. We've got a massive operating loss. One of the other ways that we help to offset that is through merch. Today's featured product is Do the Math. Now that features a high-res image of Sagittarius A star, the core of the Milky Way galaxy, which, by the way, you shouldn't be frightened of. If you're frightened of the core of the Milky Way galaxy, it's 26,000 light years away, and you should probably just do the math. By the way, you can save 15% off if you head to the Redbubble shop. So, yeah, do the math. We've shown the work. Hopefully you don't suck at math. And the equation is 8 equals capital D. So that's the featured product of the day. Again, linked below the video and on the homepage. Save 15% there by clicking that little blue box when you order. Thanks to everybody who's picked up merch. Last but not least, thanks to the Smash team, because these videos are brought to you not only at massive personal risk and expense by Smash staff and I, but also by the Gold and Silver Smash team members. There's also a Bronze membership level there. We send out email alerts because people complain about not seeing these videos on their subscription feed. So that's why we send out emails. Never miss a video again by signing up for email alerts. Just log in. And if you don't have an account, go create one at smashomash.com/smashteam. And let's move to meteorology. So, yeah, this is some accurate forecasting is what's been going on here. as Hurricane Lee breaks up into tiny bits. Now, it is still certainly some stormy seas there in the western Atlantic, as we've got the largest waves in the world, over 42-foot waves out there northwest of Bermuda. So the planet does have some large waves in other spots. The Southern Ocean features some nearly 40-foot wave zones south of Australia and south of Africa. But Hurricane Lee still takes the cake. Those are the world's largest waves. So some approximately 43-footers out there. I suspect there might be some good surf at the Outer Banks. Anyway, we'll show some forecasts about that, which have been working out exactly as expected if you've been watching the channel. Here come the world's air masses. So there are surface winds of the east. Here are jet streams of the east. Jet streams of the central world. Shout out to Sepp Kuss. Congratulations to Sepp Kuss, now likely to win the Vuelta a España, the world's third largest bike race, the Tour of Spain. The American from Durango, Colorado there, wearing the red jersey, looking like he's able to win. If he just gets to Madrid, he'll probably be the winner of one of only three three-week stage races. Anyway, here are the surface winds of the central world. Surface winds of the west. And there are the jet streams. The jet stream pummeling Hurricane Lee and breaking up its upper level winds. All right, so here come some forecasts. We're going to move this ahead until tomorrow early afternoon, because that's when the low is going to make landfall. So right around there, about 3 p.m. Eastern Time, expecting that low to make landfall around St. John, Canada there. And of course, it's going to travel over some cold water, and that is going to significantly weaken it very rapidly. So there will be some strong winds there at Nova Scotia. That's the Euro forecast. Tomorrow at 1500 Eastern Time, that's 1900 Universal Time. There's the GFS forecast in a very similar location, so the Euro and GFS forecast, they're largely agreeing. Just some minor differences on the wind in the Bay of Fundy. So very similar forecast there. There's the GFS, and there's the Euro forecast. Now let's take a look at some satellite imagery here. There is the shortwave radiation map. Let's take a closer look at Hurricane Lee, breaking down exactly as forecast. That's called understanding the physics of how weather works. Here's the water vapor map, and you can see how it's been entraining a bunch of dry, massive air. That creates huge pressure gradients and breaks down the organization of a hurricane. We showed it yesterday. There's also jet stream interaction there. Again, a lot of things working against it. And as it goes farther and farther north, it's going to break down rapidly as it travels over the top of cold water, reducing its convective potential. Those are facts. Here's our weather.gov map, the homepage of the National Weather Service, and we've got some frost advisories there in northwestern Pennsylvania. Weather.gov to get your weather alerts. And here comes some weather forecasts. This is the GFS jet stream forecast. And you can see the jet stream here is going to continue to pummel that system in the coming days. Also cold air blasting down from Canada. So that's the 72-hour GFS jet stream forecast. Here's the 72-hour GFS pressure and precipitation forecast. And you see how suddenly that system just breaks down. That is a result of the jet stream and cold water off the coast of Cape Cod. Here's the GFS sea level pressure and winds forecast. That's the 10-meter winds and the mean sea level pressure forecast. And a sudden rapid drop-off there. No surprise to our regular viewers. Last but not least, we'll show the total accumulated precipitation forecast. Wait a minute. There's the total accumulated precipitation forecast. And by the way, check that out. There are some areas of Texas expecting, like 7 inches of rain there. Dag. So yeah, also that hurricane remnant will be dropping a solid 3 inches of rain plus in large portions there of both Canada and Maine. So that's your total accumulated precipitation forecast in inches based on a 72-hour GFS model. And let's see where the lightning's been striking. Mainly in Texas, also a bit in Florida. And let's see if we have any terrestrial strikes at the time of the production of this video. So here's the current real-time lightning map. And we do have some lightning there in Texas, indeed. Once again, almost the same place we showed yesterday. Abilene. There's thunder rolling in. Some isolated but rather powerful thunderstorms there, just west of Abilene at the moment. So there's the full globe view. And we'll close out with the U.S. Doppler radar, clouds and fog, and water vapor maps. So there's U.S. Doppler radar, Alaska getting some precipitation once again. Focusing on the lower 48. There is clouds and fog. And there is your water vapor. Here's your recap. So we've actually got two things happening here in Texas. There is a blocking system ahead of this, and there is an impulsive system behind it, pushing it forward, creating huge pressure gradients. You'll see it on the water vapor map. Some atmospheric compression happening there. There is clouds and fog. And there is water vapor. That'll clear things up if your Doppler is unclear. And if you're unclear on how to forecast weather, you should be watching the channel. Anyway, thanks for watching the channel. Congratulations on realizing it exists. I'll see you soon. In the meantime, may that solar wind be at your back.